What's up, peoples? This video is to help with problem solving strategies when it comes to two object problems and the objects are moving with constant velocity. So take a second to read this problem and you'll notice that you have two cars traveling at constant velocities, both to the east. You know, one could be going west, one could be going east. They've been going both west, doesn't matter. And there are two questions that follow. One is, how far apart are they after they travel for the same amount of time? And the other question is, if they travel the same distance, what's the difference in times it takes to go that distance? So first thing I would do is realize that it's a two object problem where the objects are moving at constant velocity, and I'd get organized. I would list my variables for each. I don't know why I did that. Sorry about that. So for car A, I'm just listing velocity of A, distance traveled for A, as I write the letter B, and time traveled for A. I would do the same thing for car B. Now notice I'm not trying to fill anything in yet. That's what people tend to do, like, oh, I know this bit of information, let me write it down. Slow down. Get organized. Let's lay our puzzle pieces out on the quote paper here. And now let's fill in what we know. Because I have two objects, and I'll go down the list. Do I know the velocity? Yeah, it's 30 meters per second. Do I know how far it travels? No, I do not. Do I know how long it travels for? Yep, 1.2 hours. You're going to have to convert that to seconds by either multiplying by 3,600 seconds per hour or 60 minutes, 60 seconds. But either way, the time will be 4,320 seconds. I'll do the same thing for B. I know how fast it's going, 24 meters per second to the east, and for the same amount of time, 4,320 seconds. Should be pretty obvious that the only thing you don't know about each object is how far they travel. And at the moment that this video is being made, you probably only know one mathematical expression for constant velocity. So to get the distance traveled for A, it's distance equals velocity times time. Do you have to write this out algebraically with subscripts? No, but I'm being organized because I'm kind of like the teacher and I want this video to be, you know, nice. So the speed is 30 meters per second for a total of 4,320 seconds, giving us a distance traveled for A of 129,600 meters. I'm going to do the same thing for B. The distance traveled by car B is just the velocity of B times the amount of time it travels. That's 24 meters per second times 4,320 seconds, giving us a distance of 103,680 meters. And then to find out how far apart they are, it's pretty simple. You just subtract the two. At least I think it's simple, but I do this for a living. So 129,600 meters minus 103,680 meters gives us a distance of 25,920 meters apart. Yay! Now, some of you may be thinking, yeah, but can't you just, take the difference between the two velocities, which would be 6 meters per second, and then multiply that by the time? Yeah, that's a great idea. I like that you may have seen that. And it does work for this scenario. However, what I'm trying to show you here is problem-solving strategies, organization, listing of variables, ways that will work no matter what. As problems become more complicated, these little shortcuts that you notice don't really exist anymore, and then you have nothing to rely on. So please trust me. Just get organized and follow the problem-solving strategies suggested in class and on this video. So let's address the next question, which I believe was, if they both travel 40 kilometers, how far apart will they be? Or excuse me, how much time does the faster car have to wait for the slower car? So again, I'm going to get organized. I'm going to list my variables. Car A, how fast is it going? Distance traveled, time. Car B, velocity of B, distance traveled by B, delta t of B. Yes, I forgot the A over there. I will put it in. We know 30 meters per second, and it travels a distance of 40 kilometers. You are expected to be able to convert kilometers to meters. Kilometers are bigger than meters. They're much bigger, 1,000 times bigger. So this is 40,000 meters. Here, for the other car, it's 24 meters per second, and it travels the same distance, 40,000 meters. Should be pretty clear because right now at this point in the year we only have one expression with 3 variables, and in each case you are missing one of the variables. So the time is distance over velocity. I had to think about that for a second, and I feel bad because I should know better. So 40,000 meters divided by 30 meters per second gives us a time of 1,333 seconds. For car B, I'm going to do the same thing. How far does it travel and what is its velocity? So we get 40,000 meters over 24 meters per second, giving us a time of 1,667 seconds. A little bit of rounding there. And how long do they wait for each other? Well, just take the difference. 1,667 seconds minus 1,333 seconds is 334 seconds. That's how long the faster car had to wait, about 5.5 minutes, if my mental math is okay. One quick summary here. The general strategy is that you want to list your variables for each object. Please remember that I listed the variables for each object before even trying to fill in numbers. Don't be a number hunter. Get organized first. And then when it comes to these kind of problems, the objects are either traveling for the same amount of time and we're going to compare the distances, or they're going to travel the same distance and we compare the times. There's not much else we could do with these constant velocity problems. And finally, although this problem didn't have anybody going west, just be careful with direction. Remember, if it's traveling east, that's positive, but it's traveling west, it's going to have a negative displacement. It's also going to have a negative velocity. Hope this video helped, and I'd give it 3 out of 5 stars. I wouldn't change a thing.